understand. So you don't have to read the textbook. In fact, all of this posting, a lot of towards the end, is going to be in next semester's course. So all this developmental down here, that is actually the development of the baby, is going to be next semester. But you need to know where the cells come from that are going to form the various organ systems that we're going to study for the rest of the year. And you need to know the development of the nervous system, development of connective tissue and muscle. And so we're going to focus on those areas today. So if you look, nothing has actually been highlighted here. Second page, I have a blue box and I have a green box. So blue box and green box, that's where you're going to spend the most time today, or at home when you're reading. So this blue box, you can see that there's a stump here and a stump here, and you got some arrows going along a trough in the center. And then this is going to, you take a cross section through that, and that's what this is representative of. You've heard of amnion, you know that's the sac that the baby's going to grow into. And we've got migration of cells from the primitive streak. But we're not going to focus on the primitive streak, but I want you to see that we've got mesenchymal cells. Mesenchyme are embryologic cells that are going to develop into various types of tissues. So we got migration of cells from the primitive streak, which is on top. They're migrating down through a hole, and then they're going to go underneath this top layer and above this bottom layer. So look for the next blue box, and that's information that is a little bit bigger, a little bit more easily distinguished. We take the top off of our amnion and look down in this plateau of cells. You can see that there's a primitive streak here and a little dot. That opening is where these cells dive down to then migrate forward and back underneath the top layer and the bottom layer. We've got this cord of specialized cells that are doing this migration anterior and posterior. We look, what is anterior? Cardiogenic area. Anybody not know what's going to develop in the cardiogenic area? Heart. So up in the top, you don't even have a brain or a neck yet. You've got a cardiogenic area that's way up here. And then you look coelomic space. What is a coelom? Anybody know? Okay, so you don't know what a coelom is. So you got coelomic spaces. And then you look over here, and you've got coelomic space and intraembryonic coelom. And then on either side, you've got somatopleur and splanchnopleur. This is when you get into terms like, oh my God, this is really hard. Except if you break it down, pleur, you have pleura. Pleura are in the areas of your lungs. These are cavities inside your body. You think pericardial, that is a cavity inside your chest. You have pleural cavities that are in your chest. And then you've got abdominal area, and you've got a peritoneal cavity, and you've got an abdominal cavity. All of these are developing from these coelom spaces. If you look back at chapters 1 and 2, you find that you have your ventral body coelom, which is your thoracic and your abdominal region. These are your ventral body coelom. Thoracic area, plural, pericardial spaces. And in the abdominal area, you've got an abdominal cavity and you've got a peritoneal cavity. So don't get freaked out, just break the terms down. You've got, you've got coelom. These are the cavities that are going to develop. And then you've got soma. What does soma mean?
Body.
Yes, body. So what is, you have soma of a neuron. That's probably what you're remembering soma from. But you also have somatic nervous system. The somatic nervous system runs what? Yeah, muscles. Muscles are surrounded by connective tissue. You have also a somite. So a somite is going to spread laterally, and it's going to form arm muscles down here, muscles in your axial skeleton, go from your hips down your legs. You don't even have legs yet, but these are going to migrate. They're going to pull connective tissue and nerves with them, and you're going to develop your muscular system and your nervous system in your appendicular skeleton. Neural folds. Neural, must be related to nervous system. Yay! But it's flat. This whole thing is flat. If you look at it, it's ectoderm. And in here we have mesoderm. And in here we have endoderm. So we're going to find we're going to have ectoderm. What is most of the ectoderm going to be? Skin. But part of the ectoderm is going to form your nervous system. But nervous system's inside. So how does it get inside? First it's got to fold, and then it's got to invaginate and separate from the ectoderm. So we have, oops, sorry, like I say, new buttons. Press the wrong thing. Okay, so this center area is the neural groove, and then we have the neural folds that are going to come up and fold. It's like two waves that are coming up and touching medially. They're going to attach to each other, and they're going to form a neural tube. Oops. I'll get this pretty soon. Okay, so going on a little bit further, we had neural groove, we have neural folds forming, and now we have something else, neural crest. So neural crest is going to separate from the central area. The central area is going to close off and form a neural tube, and these neural crests are going to be out to the side. Anybody remember what neural crest formed? So I only know Eric, so I can only look at Eric. What does a neural tube form? Not the spine, spinal cord, and what's at the top of the spinal cord? Brain. So we've got our neocortex, which is our telencephalon. We've got di and ramencephalon that we're going to learn all about next, towards the end of the semester. So we've got what we call our brain, and then we've got a little brain back there, cerebellum. We've got a brain stem, and when you go below the foramen magnum, you've got a spinal cord. That all develops from the neural tube. what do you need to run the rest of your body? Nerves, peripheral nerves. So we've got a lot of nerves in the neural tube area. We've got a lot of nerves up here, a lot of nerves going up and down, but we also need peripheral nerves. So we know what's going on in our environment, and we can control our environment. So neural crest will form the peripheral nervous system. And it also has some cells that will migrate different places. Odontoblasts come from the neural crest. In the center of your adrenal glands, you got hormone secreting cells. They come from the neural crest. So neural crest cells migrate different places and do different things, but as they connect to the central nervous system, they form our peripheral nervous system. What is left of all these magic cells? All those magic cells that dove down through the hole and migrated front and back, they form a structure called the notochord. And that is labeled right here, notochord. So they have all the growth factors, all this magic that is leaving these cells, changing the surface ectoderm into neural tissue, changing the tissue to either side into mesoderm that's going to form your muscles, and the peripheral nerves are going to get pulled out with those. And then also changing the cells down below that were actually hypoderm early on into endoderm. So now we've got a 3-layered disc. We've got nervous system forming, we've got muscles forming, nerves, peripheral nerves forming. Our cavities are also forming here. Still doesn't look like anything at all, but things are developing. This notochord, going to find out when we get to bones, it's going to get obliterated in your vertebral column by the bone of your vertebrae. But if you are in KRS, you know about herniated nucleus pulposus. You've not heard about that? Not yet? Okay. When you have a herniated disc, your age, most likely, it's the central area of the disc. The outside is fibrous connective tissue, but there's a gelatinous center. And that pulpy center, when you have some kind of acceleration of the space between your vertebrae, that gelatin goes out and presses on nerves, and oh God, excruciating low back pain or no muscle control because you pressed on your motor nerves. So you put person in traction and the gel comes back to the center. Problem solved, except now you've got a chronic condition probably. You've got to keep those muscles strong or it can happen again. So notochord gets obliterated, except it persists as that gelatin in the center of your disc. When you get old like me, it gets all desiccated and it will fracture and pieces go out, press on nerves, but it doesn't herniate. And there's some good models that will show you about that in that. Okay. Let's take a break, and then we're going to come back and talk about some terms that are shown here that are going to be important for understanding what we're talking about later on. So a 10-minute break, and then